So this is the section 1 from the test 4 material, but it's going to help you review integrals that you need to know. All right, so the first step of solving something like this is called a differential equation because it has a derivative and an equal sign. So the first step is to rewrite y prime as dy over dx. There we go. dy over dx cosecant cubed, of 3x equals -1. Then I want to multiply by dx. So I'm going to get dy. Oh, and I want to divide through by cosecant cubed of 3x because I want to get all the dx's on this side. So I want to separate the variables. So I have this. Okay, so you can see I have all the x's on this side and all the y's on this side. There's no y really there. And then you know, oh yeah, I need to integrate. It's screaming for integral signs. So the integral of 1 dy is y. On this one, I'm going to take the time to rewrite it because you know this is the same thing as saying sine cubed, right? 1 over 1 cosecant cubed is sine cubed. Okay. Oh, you recognize this. We've been doing these, right? So I'm just going to bring it up here. So y equals, and I'm going to do a w substitution, right? So I get rid of that. So I get 1/3 integral of sine cubed of w. Now I know I can make the good du. So I make sine squared of w, sine of w, dw. Okay, so there's my du. du is sine of w dw. So u is cosine. Oh, right. This is the negative issue. So the best way to take care of this is put the negative here. So then I want to make my u substitution work. So I need to change this to cosines. So let me just carry things down here. So I have 1/3. I'm going to make this 1 minus cosine of squared of w, and then a sine of w dw. So then y equals 1/3. So now let's substitute in. So I'm going to put cosine in here. So I have 1 minus u squared. And then instead of sine, right, I'm going to put in a negative du. So negative d. Oh, and look at that. I lost my negative sign. So there was a negative sign out here. There was a negative sign, negative sign. Now the two negative signs make a positive. Okay, now I'm going to take the antiderivative. So I get 1/3. And you know the integral of, sorry, that's kind of messy. It looks like so this is a 1 minus a u squared. Integral of 1 when you're in u land is u minus u cubed over 3. Now I'm going to put all of the things back in, right? So u is equal to cosine of w, and then w was 3x, and then I have a minus 1/3, and then I'm going to put the cosine cubed of 3x back in, and then it should have a plus c. And that's the answer for number 1. All right, so let's move on to the second one. So the second one, I want to, again, start with rewriting y prime as dy over dx. Okay, so here we go. So I'm going to pull this 1 over y off to the side. So dy over dx is cosine squared of 5x. Again, I want to get the x's on one side and the y's on the other. So I'm going to multiply through by dx. There it is. I can see it's screaming for integral signs. Okay, so this gives me ln of y. And I'm always going to put the plus c on the x side. And how do we take the antiderivative of that? You know we want to use half angle formula. So that's 1 plus cosine of 10x. So I have ln of absolute value of y, carry along the 1/2, take the antiderivative of 1, that's x, and this gives me a 1/10 sine of 10x plus a c. We need to finish by solving for y. So solving for y, I take the e of both sides, right? So I put that up in the exponent, sine of 10x plus a c. So that's the answer for number 2. All right, so one more. So again, we want to start by rewriting y prime as dy over dx, and then separate the variables. Then we can integrate each with x's and x's and dy's and y's. All right. Make it clean enough so you can read. Okay, here we go. So I'm going to rewrite this. So I get y times dy over dx. And I'm just going to go slow, right? So I'm doing this one up here, equals tangent of 2x. So I'm going to multiply by dx and divide by cosine, right? So I'll get y dy equals tangent of 2x divided by cosine of 2x times dx. Now I'm ready to integrate. Integrate. This gives me y squared over 2. And then over here, I don't usually see tangents and cosines together. Oh, but I can rewrite this. This is the same thing as saying tangent of 2x, 1 over cosine. Isn't that the same as saying secant? It is. So there's nothing profound here. This is just an easy U substitution or La Jolla theorem. So I would get secant of 2x plus a c. Okay, the last part I need to do is I need to solve for y. So I get y squared is equal to secant of 2x, and I can put 2c in there, it doesn't matter. Then I'm going to take the square root of both sides, so I'll get y is equal to the plus or minus secant of 2x plus a 2c. And soon we'll be given information to solve for the c.